We use the commutative and associative properties to multiply terms. We also use the product rule for exponents to add the exponents on the same variables. Let's look at some examples. Find each product. 3x to the fourth power times 5x to the third power. By using the commutative property and associative properties, we can rearrange the numbers and letters in order to simplify. We now have 3 times 5 times x to the fourth power times x to the third power. We can now multiply and use the product rule on the exponents. This will give you 15x to the seventh power. In the next example, we have negative 4a to the third power times 3a to the fifth power. Again, we rearrange the terms to get negative 4 times 3 times a to the third power times a to the fifth power. This will give you negative 12a to the eighth power. In the last example, we have 2m to the second power, z to the fourth power, times 8m to the third power, z to the second power. We can rewrite this as 2 times 8 times m to the second power times m to the third power times z to the fourth power times z to the second power. After we multiply, we get 16m to the fifth power, z to the sixth power. To multiply polynomials, we use the distributive property. Let's look at some examples. Negative 2 times 8x to the third power minus 9x to the second power. By using the distributive property, we can rewrite the problem as negative 2 times 8x to the third power minus 2 times negative 9x to the second power. Next, we multiply and we get negative 16x to the third power plus 18x to the second power. In the next example, we have 5x to the second power times negative 4x to the second power plus 3x minus 2. Again, we rewrite the problem as 5x to the second power times negative 4x to the second power plus 5x to the second power times 3x plus 5x to the second power times negative 2. Again, we multiply and we get negative 20x to the fourth power plus 15x to the third power minus 10x to the second power. In the last example, we have 3x minus 4 times 2x to the second power plus x. We can rewrite this problem as 3x minus 4 times 2x to the second power plus 3x minus 4 times x. We use the distributive property again to rewrite the problem further as 3x times 2x to the second power plus negative 4 times 2x to the second power plus 3x times x plus minus 4 times x. Next, we multiply and combine like terms. Our final answer is 6x to the third power minus 5x to the second power minus 4x. Sometimes when multiplying polynomials, we run into special products. One special kind of polynomial product is the product of the sum and difference of two terms. The product of the sum and difference of two terms, x and y, is the difference of the squares of the terms. In other words, x plus y times x minus y equals x to the second power minus y to the second power. Again, let's look at some examples. In the first example, p plus 7 times p minus 7. If we follow the definition above, we rewrite the problem as p to the second power minus 7 to the second power. This will give you p to the second power minus 49. In the next example, 2r plus 5 times 2r minus 5. We again rewrite the problem as 2r raised to the second power minus 5 raised to the second power. This will give you 4r to the second power minus 25. In the last example, 6m plus 5n times 6m minus 5n, we rewrite the problem as 6m raised to the second power minus 5n raised to the second power. This will give you 36m to the second power minus 25n to the second power. Another special kind of polynomial product is the square of a binomial. The square of a binomial is the sum of the square of the first term twice the product of the two terms and the square of the last term. This definition applies when your binomial is a sum or a difference. In the first example, we have the binomial m plus 7, which is raised to the second power. By using the definition, we rewrite the problem as m to the second power plus 2 times m times 7 plus 7 to the second power. Upon multiplying, we get m to the second power plus 14m plus 49. In the next example, we have the binomial p minus 4 raised to the second power. Again, using the definition above, we rewrite the problem as p raised to the second power minus 2 times p times 4 plus 4 raised to the second power. After we multiply, we get p to the second power minus 8p plus 16. In the last example, we have the binomial 2p plus 3v raised to the second power. After rewriting, we get 2p raised to the second power plus 2 times 2p times 3v plus 3v raised to the second power. After we multiply, we get 4p to the second power plus 12pv plus 9v to the second power. You should look over the examples on the web page and then test your knowledge using Test Yourself.